So eventually, I got the feeling that this whole thing, I don't think I can explain it properly in a video or two. So I think it will be a kind of a series, maybe short lecture series. And I know that I don't speak fast, so it will be slow and short. So it's like 2 3 videos in terms of fast and proper. Maybe I don't know. If you don't get any of this, don't mind. Let's focus on uh, why we're here. Okay. So the question is clear, right? I hope that the question is clear. Wait a second. I hope that the question is clear. Um, with that, let's start our procedure. Yep. With that, let's start our procedure. Okay. So what I want to introduce is to Markov chains. I won't introduce you to. Okay, never mind. Let's directly jump to a regular Markov chains. Yeah. So couple of definitions first. Let me change the color. No, no. Here. So ergodic chain. Um, yeah. How should I put it? So suppose that a system has some number of states. So in this case, it's like 7 cross 7 states. By states, I mean in this case, where the ball is. So if the ball is in, let's say, 3 comma 4 square, then I say that it's a particular state. So in this case, we have mod SI equal to 49, right? Yeah. So ergodic chain is like, yeah, SI means a particular state. SI, this curly thing means in my notation, the set of all states. Where each state I denote by SI. Yeah. So ergodic chains. What are these? So you have, let's say, many states denoted by line. I mean, I'm denoting it by line, not line points. Sorry. Uh, so a chain is said. Let me explain what is chain. A chain is basically hopping around, like you jump from one state to another state, maybe remain in that state, or maybe always change your state so that no two consecutive time units you stay in a particular state. uh, you get a feeling for what the chain means, like a sequence of steps, not a sequence of states. By steps, I mean in between two states you take a step, so that is step. So I won't confuse step with states. Never mind. Yeah. So you have si to s1 s2, like this to sn steps, and the chain is said to be ergodic if from any state you can go to any other state by some finitely many steps. Yeah, steps. Maybe this. Yeah. So you went from s1 to let's say 6, maybe 1 2 3 4 5 6, s7, and say 1 2 3 4 5 6 steps. So yeah, some finitely many steps. And also our number of states is finite, so that guarantees that saying that it reaches from s1 to s7 is finite. It makes sense. This statement makes sense. Yeah. So this is what ergodic chains mean. I won't write down anything as such because it's not really healthy for my hands to write on a screen because I don't have a pencil. As simple as that. Okay, never mind. So now let's define a regular chain. So what's a regular chain? A regular chain is again a chain wherein after some time period, n number of not time period, n number of time units, um, there is some positive probability of you going from Si to Sj, where I and J run over all the possible states. So yeah, that is what regular chain means. Basically, uh, in a regular chain, after that n number of time units, you cannot say that your state can't be Si, because there is some non-zero probability of your state being in Si, regardless of from where you start your chain, regardless of the state from where you start your chain. Yeah, so that is regular chain, and this thing comes in